Imagine committing 15 years and $15 billion to a single construction project before it produces a single dollar of revenue. Every year of delay adds hundreds of millions in interest payments on money you already borrowed. Every regulatory review can add months. Every design change ripples through a structure made of some of the most precisely engineered concrete and steel on the planet. This isn't a worst-case scenario. This is what a normal nuclear power plant construction project actually looks like. And the bill behind it will change how you think about where your electricity actually comes from. Most people assume electricity just happens. You flip a switch, the light turns on, and somewhere far away, a power plant quietly does its job. What almost nobody thinks about is what it takes to build that plant in the first place, especially when that plant is nuclear, because nuclear power is unlike any other form of electricity generation on Earth in one critical way. The vast majority of its total cost is spent years before it ever produces a single watt, and that upfront spending is so enormous, so precisely regulated, and so vulnerable to delay that it has become one of the most financially treacherous construction projects any company or government can undertake. Let's start with the site itself, because before a single foundation gets poured, a nuclear project has to clear a regulatory gauntlet that can take the better part of a decade on its own. In the United States, a company seeking to build a new reactor has to submit an application to the Nuclear Regulatory Commission that can run into the tens of thousands of pages, covering everything from seismic risk analysis to detailed evacuation planning for surrounding communities, to the precise engineering specifications of every safety system in the design. That application process alone, before construction even begins, can cost hundreds of millions of dollars in engineering studies, environmental impact assessments, and legal work, and it can take anywhere from 5 to 10 years to receive final approval, depending on the country and the specific design being proposed. Here's the detail that surprises people. During all of those years of regulatory review, the company is spending money constantly on the engineers producing the documentation, on the consultants managing the regulatory process, on the legal teams responding to public comments and challenges, and on the site preparation work that can begin even before final approval, all while generating zero revenue and, in many cases, paying interest on money already borrowed to fund the process. This is fundamentally different from almost any other kind of power plant. A natural gas plant can go from approval to operation in a few years. A nuclear plant's pre-construction phase alone can take longer than an entire gas plant's construction and operational ramp-up combined. Now let's talk about the construction itself, because this is where the numbers reach a scale that's genuinely difficult to comprehend. A modern nuclear reactor requires a containment structure built from specialized high-density concrete, reinforced with steel rebar, engineered to withstand not just normal operational stress, but extreme events, earthquakes, and in some designs, even the direct impact of a large aircraft. That concrete isn't ordinary construction material. It has to meet nuclear-grade specifications, tested and certified at every single pour, with inspectors verifying quality at a level of scrutiny that would be considered wildly excessive on almost any other construction site on Earth. The reactor pressure vessel itself, the massive steel structure that actually contains the nuclear fuel and the reaction, has to be forged from specialized steel alloys, capable of withstanding decades of radiation exposure without becoming brittle. Only a handful of manufacturing facilities in the entire world are certified to produce components at this level of precision, which means these components are often ordered years in advance, manufactured over a period of a year or more, and then transported using specialized heavy-lift equipment, because a single pressure vessel can weigh several hundred tons and cannot be manufactured anywhere near the final construction site. Let's talk about labor, because a nuclear construction site is one of the most heavily staffed construction projects that exists. At peak construction, a single nuclear plant project can employ several thousand workers simultaneously: welders, electricians, pipe fitters, and a huge population of quality assurance inspectors, whose entire job is verifying that every single weld, every single bolt, and every single system meets nuclear-grade specifications before it gets covered up or connected to anything else. This isn't standard construction inspection. Every major weld on critical systems can require radiographic testing, essentially an X-ray of the weld, to verify there are no internal defects, because a flawed weld discovered after the plant is operational could mean shutting down the reactor and cutting open completed structures to make repairs. a scenario every project manager is desperately trying to avoid. Here's where the financial risk becomes genuinely dangerous. Nuclear construction projects are notorious for delays, and those delays compound in a way that's uniquely punishing for this industry. If a project is financed partly through borrowed money, which almost all of them are given the scale of investment required, interest charges accumulate on that debt every single day the plant isn't finished and generating revenue to pay it back. A delay of even 1 year on a multi-billion-dollar project can add hundreds of millions of dollars in additional interest costs alone, without a single additional brick being laid. And delays in nuclear construction aren't rare exceptions. Multiple major nuclear projects in recent decades have taken years longer than originally planned and cost multiples of their original budget, sometimes ending up costing more than double or even triple the initial estimate by the time the plant finally begins commercial operation. One recent nuclear plant expansion project in the southeastern United States, originally estimated at a fraction of its final cost, ultimately required over $30 billion combined across its reactor units and took roughly 7 years longer than originally scheduled. That kind of overrun doesn't happen because the engineers don't know what they're doing. It happens because nuclear construction sits at the intersection of extraordinarily complex engineering, an equally complex regulatory environment, and a supply chain for specialized components that has, in many countries, atrophied over decades of reduced nuclear construction activity, meaning fewer suppliers exist who can produce these components quickly, and those that do exist can command premium prices and extended lead times. If you're finding these hidden construction realities as fascinating as we do, hit subscribe, because every week we break down what it actually costs to build and run the world's most complex systems, the numbers nobody puts in the headlines. Let's talk about what happens after construction is technically finished, because even then, the plant can't just start generating electricity for sale. There's an extensive commissioning process, testing every single system under increasingly realistic conditions, first with no nuclear fuel loaded at all, then eventually loading fuel and bringing the reactor to what's called criticality for the first time, a carefully monitored process where the nuclear reaction is allowed to begin under intense scrutiny from both plant engineers and independent regulatory inspectors. This commissioning phase alone can take the better part of a year, and during that entire time, the plant is consuming money, paying its now substantial workforce, running expensive test procedures, without generating any commercial revenue at all. Let's talk about the financial structure underneath all of this, because it explains why so few private companies are willing to build nuclear plants without government support. The combination of a decade-plus timeline before any revenue arrives, the risk of multi-billion-dollar cost overruns, and the sheer scale of capital required, often tens of billions of dollars for a single project, makes nuclear construction one of the riskiest large infrastructure investments in the world from a pure financing perspective. Many recent nuclear projects have relied on government loan guarantees, meaning the government agrees to back the debt if the project runs into serious financial trouble, specifically because private lenders alone are often unwilling to take on this level of risk without that backstop. Here's the number that puts the whole picture together. A single modern nuclear reactor, from initial site selection through regulatory approval, construction, and commissioning, can cost anywhere from $10 to over $30 billion, depending on the design, the country, and how smoothly the regulatory and construction process goes, and can take anywhere from 10 to 20 years from initial planning to commercial operation. That entire span of time and money is spent before the plant generates a single dollar of electricity revenue, which means the financial risk sits almost entirely on the front end of the project, years before anyone can know for certain how smoothly operations will actually go. So why does anyone still build these things? Because once a nuclear plant is actually operational, it becomes one of the most reliable and long-lasting sources of electricity that exists. Unlike a solar farm or wind installation that depends on weather conditions, a nuclear plant can run at near full capacity continuously for decades, often licensed to operate for 60 years or more, generating enormous amounts of carbon-free electricity for a population that, once the plant is finally running, benefits from decades of stable power generation that isn't directly tied to fluctuating fuel prices the way natural gas plants are. The upfront cost is genuinely staggering. But for a plant that can run reliably for 6 decades, that enormous initial investment gets spread across an operational lifespan that very few other types of power generation can match. So the next time you flip a light switch and the room simply lights up, remember what that simplicity is actually built on, if the power behind it happens to come from a nuclear plant. You're looking at the end result of a decade or more of regulatory review, specialized steel, forged in one of a handful of certified facilities worldwide, thousands of construction workers laying nuclear-grade concrete under some of the strictest quality inspection standards in any industry, and a financial bet, often backed by government guarantees, that took over a decade to pay off before it generated a single dollar of revenue. The switch is instant. The plant behind it took a decade to build. Disclaimer: this content is for educational and entertainment purposes only. Operational costs are estimates based on available data.